Welcome to this issue of Spacecraft Guide, the channel that describes how the most iconic spacecraft in history work. This week, we will be going over the power temperature selector switch and the inverter switch. We will also go over what an inverter switch does and how it works. For our Patreon subscribers, we will explain why we have to have an inverter on the Apollo spacecraft to begin with. This week on the lunar lander, we worked on a couple more switches over here. We worked on the power temperature selector switch and the inverter switch. First, we're going to talk about the power temperature switch, and that switch relates directly to the volts indicator and the amps indicator. When you click on the power temperature selector switch, the power temperature selector switch page comes up. And what this switch does is it enables monitoring of the volts and current of the 6 electrical power system batteries, monitors the AC and DC bus voltage and isolation of malfunctioning battery, either the overcurrent, reverse current, and over temperature condition. Now you can see we have all the batteries here, 1 through 6. And so when you select position 1, you get battery 1, and you select the battery number 1 to be monitored on amps and volts indicator and on battery fault component caution light. Now when you come over to this side on the bus, you see you have commander. Come down here, and commander bus means that the voltage of the commander's DC bus is displayed on volts indicator. In commander bus or the lunar module pilot bus and AC position, the amps indicator readings have no significance, so it doesn't matter what's on there. And then down here, when you go to SE, that's basically here the LMP bus for the lunar module pilot, and the SE position is basically the lunar module pilots. If you go all the way down to AC, you get the voltage of the AC bus displayed on the volts indicator, and the indicator reading is within the band, which is 112 to 118 volts AC. The next switch we worked on last week is the inverter switch. And when you click on the inverter switch, the inverter switch page comes up. And what the switch means is, or what the inverter switch does, is it controls the application of AC power to the AC bus. The AC bus voltage is displayed on the 28 voltmeter when the power temp monitor switch is set to AC bus. Number 1 connects inverter number 1 to the circuit breakers that supply the AC buses, and 2 does the same thing for inverter 2. But why do you need an inverter switch? What's the difference between AC and DC power? Well, we're going to explain that now. In this image, we see how direct current flows. As you can see, it goes in one direction. The electrons flow through the circuit into the light bulb, producing light, and then coming back to the battery. And this goes in one direction. As you can see, this is direct current. This is alternating current. As you can see, the electrons move one way, then they move the other way. And that continues through the wire. So the electrons really aren't moving per se in one direction to start and end up. They're moving back and forth. Now, what that generates is, in the light bulb, as you can see, the light bulb, when the power is going, the light bulb lights up. When the electrons stop, the light bulb actually turns off. And then as the electron goes the other way, the light bulb lights up again. Now, this happens 60 or more times a second in your house. That's why you can't really tell with the light that it's going on and off. That is a difference between direct current and here alternating current. And not only does that work with your light bulb, but it works with all electronic devices that run either DC or AC power. So how do you turn DC power to AC power? And the answer is with switches. So what they did in Apollo with the inverter is they took the power from the battery, one positive and one negative, and they switched the direction over on this side using switches. They turned it on one way and then switched it back the other. Now they did this for these machines 400 times per second or 400 hertz. So when you see 400 hertz plus or minus whatever, 8 or 9 hertz, that's what they're doing. Every second, these switches are changing 400 times. So why would you have an inverter to convert DC power to AC power on the lunar lander to begin with? Well, if you want to find out the answer to that question, subscribe to our Patreon page at patreon.com/SIVRmuseum, and you'll be able to find that answer. And also, you'll be able to support more videos like this.